Hey guys, I hope we've gotten some of these figured out on our own, but we're going to go through them together here a little bit and maybe we'll understand some of this stuff a little bit better before we head into our next unit. Number 1 says Jada is 3 years older than twice her brother's age. 3 years older than twice her brother's age. We are supposed to select all the equations that correctly represent the relationship between Jada's age, J, and her brother's age, B. So on a problem like this, sometimes it's a little bit helpful if we sort of just make an example, because I think it's hard to go from these words to equations that look like this. So let's try an example. Let's say that Jada and her brother, okay, it says that Jada is 3 years older than twice her brother's age. So let's just pick an age for the brother. Let's say the brother's 5. So what is twice her brother's age? Twice her brother's age means 2 times, right? So 2 times 5 is 10. And then 3 years older than that would be 10 plus 3. So Jada must be 13. Okay? So now what we can do is we can go to these equations and kind of test them out. On A, this is saying that Jada is 2 times her brother's age plus 3. Okay? So if you were to plug in 5 for B, 2 times 5 is 10, 10 plus 3 is 13, and that's Jada's age. So I believe that A is a good example of that equation. I think A is the one that should jump out at you and you should go, yeah, twice the brother's age plus 3. That goes with what that says. As we go through these, we'll test each one and then we'll see how many of them work out. So looking at B now, if I take the brother's age of 5 and add 3 to it, right, I'm going to add first because it's in the parentheses. 5 plus 3 is 8, and so then I just have 2 times 8. And so that would suggest that Jada's age is 16, which is not the case. So we've got to say that B does not work. On part C, if I take the brother's age and divide it by 2, 5 divided by 2, I'm going to get 2.5. And then I subtract 3, and I'm going to get a negative number there. So that one really doesn't turn out very well. Now, these last 3, they sort of switch things around, right? These first 3 were J equals something, and now we have B equals something instead. So I'm taking 2 times Jada's age plus 3. Well, 2 times Jada's age is 13 times 2, so 26 plus 3. That's going to be way too high for the brother. Okay, so D does not work. E, I'm taking Jada's age minus 3. Okay, so let's do 13 minus 3 divided by 2. 13 minus 3 is 10, and 10 divided by 2 is 5, which is the brother's age. So I think E also works. The last one, F, J divided by 2. So Jada's age divided by 2 minus 3. And 13 divided by 2 is going to be 6.5. 6.5 minus 3 is 3.5. And that is not what the brother's age is. Okay, so that's what we're looking for on number 1. Hopefully you got parts of that correct. If I go on to number 2, we have a rectangle. it describes its length as x and its width as y. We're supposed to select all the statements that must be true. So then it starts talking about perimeter, and then separately talks about area. Okay? And so we need to think, how do I find the perimeter of a rectangle? How do I find the area of a rectangle? Okay, so perimeter of a rectangle is adding up all the sides, right? So length plus width plus width. Okay, and if we want to do this more easily, maybe, let's talk with the things that they use here. So they use x and y for length and width. So let's start working through some of these. A, perimeter is x plus y. Well, we've got to have two x's and two y's to get the perimeter. So A is out. B, the perimeter is x times y. If I take the length times the width, what does that give me? If I take the length times the width, I think that's going to give me my area. So we're going to talk about that here later. So I think B is out. On C, the perimeter is 2 times x plus y in parentheses. Think about what happens when we distribute the 2. Take 2 times x, 2 times y, you're going to get 2x plus 2y. And we just said perimeter is 2 x's and 2 y's all added together. So these two things are the same. So C is a good equation for us to use, a good expression. D, they're going to take 2 times x and 2 times y. Well, that sounds like this area formula doubled, right? And we don't want area right now. We want perimeter, so D will not work. Last attempt at perimeter. We're saying 2x and 2y. Well, isn't that what we said up here, right? We said this was 2x plus 2y, or we said the 2x's and 2y's. That's perimeter, so E is another good example. So then looking at those three choices for area, do any of those choices seem to go with this formula that we created right here? Seems like G does, right? G is taking x times y. This one is too big, H. H is too much, it's doubled. And then F is going to be taking the length plus the width, and that won't get us area. So I think we need to go with C, E, and G. Okay, turn the page with me. We have number 3 here. Select all the proportional relationships. Something that's important to remember about proportional relationships is they must go through the origin. So if I have x equals 0, then y must also equal 0, right? So they must go through this point right there on the graph, 0, 0. So A, that line, does not go through 0, 0. So A is not going to be a proportional relationship. Part B gives us a little word problem. It says a train is traveling at a constant speed of 60 miles per hour. The number of hours the train has been traveling is T. The number of miles the train has traveled is D. So we're basically going to be taking 60 miles times however many hours. That's going to equal the distance traveled. So we said that if x is 0, y must be 0 for it to be a proportional relationship. Okay, so in this case, our variables aren't x and y, it's d and t. But if I plug 0 in here for the time, as in if I've traveled 0 hours, how many miles have I traveled? If I haven't started going anywhere yet, my distance is 0. Okay, so my ordered pair would be 0 hours, 0 miles. So B is a great example of a proportional relationship. Okay, let's keep going. C, the relationship is represented by this table. So they don't give us when x is 0, but let's look at what the pattern is here, okay? When I go up 1 on the x, so from 3 to 4, y increases by 6. When I go up 1 on the y, or on the x, from 4 to 5, we now add 12. So we're not even constant right here, 6 and 12. Sometimes it changes by 6, sometimes it changes by 12. We can't even go back and predict what 0, 0 would have been at. It's not going to be on a straight line. So C is out. 2 more choices. D, y equals 3x, where x are both positive numbers. Well, this one's a tiny bit tricky, if you ask me. When you think about a proportional relationship and you say it's got to go through 0, 0. If x is 0, then y is 0. Well, when you first look at this equation, you go, okay, 3 times 0 equals 0, right? So that works. Seems like a great answer. Now, could you say x and y are positive numbers? Well, if there's 0, are they positive? I don't know. I think that's debatable. So I'm going to go ahead and say that D is a good example of a proportional relationship. And it is. I think this x and y are positive numbers part maybe is a little bit misleading or confusing. But we're going to let that go. The last one, looking at E here, y equals 1 over x. If I plug 0 in for x, what happens? What happens when you go 1 divided by 0? You don't get a number, right? You get an error in your calculator. You're going to get something that's undefined. You cannot divide by 0. So that's going to be a problem for E. Okay, so on number 3, we're going with B and D. Last example here, number 4. Given the equation y equals negative 3x plus 2.5, then on part A it says, when x is 1, what value of y makes the equation true? So all you need to do here is plug in these numbers. When x is 1, y equals negative 3 times 1 plus 2.5. So y equals negative 3 times 1, it's going to be negative 3, plus 2.5, and then I need to add those two numbers, okay? This is something that we have trouble with sometimes. If I am adding when I have a negative starting point, okay, here's negative 3, here's 0, negative 2, negative 1, okay? So I'm starting here, right? I'm starting at negative 3, I'm adding 2, 2.5 actually. But if I add 2, here's 1, 2, and then another half, I'm going to end up at negative 0.5. So all you're doing here is plugging in the number that they give you and then solving it out. Okay? On part B it says when x is negative 1.5, what value of y makes the equation true? So we go back to our equation. We plug in negative 1.5 for x, and we solve. Okay, we're going to need to multiply. Negative 3 times negative 1.5 gives us, I believe it's positive 4.5. And then I'm saying 4 plus 2 is 6, and a half plus a half is 7. So y equals 7. Now, the last one, don't let it trick you. You're feeling confident now. You've got this thing figured out. They say when y is 8.5, what value of x makes the equation true? So they flipped it on us. So instead of plugging 8.5 in for x, plug it in for y. Better yet, let's plug it in over here. 8.5 equals negative 3x plus 2.5. Now, you know how to solve an equation like this because we spent a unit solving equations like this. Subtract 2.5 from both sides. We have negative 3x equals 6. Then we divide by negative 3 and end up with x equal to negative 2. Okay, thank you for working hard on this today. Please make sure you watch all the way through to the end of the video so that you can get full credit.